Alright, this is question number 7 on the review packet. Let's go over this one together. So to find the experimental empirical formula of a compound, a student heats a piece of sulfur in a crucible. We've got the data from the experiment, and our goal is to find the empirical formula. The information here is meant to mimic the lab we did in class when we took the magnesium and we cut it into little pieces and then we burned it inside of the crucible, which is a little guy with the acorn looking top. And when we did that, what we had inside was the magnesium in little chunks. And we got its mass beforehand, so that would have been the mass of the crucible and the magnesium. And we knew what the mass of the empty crucible was. After we did the reaction, so we heated it strongly under a flame. And what that did was when it heated up the magnesium, it let oxygen come inside. Once we popped open the lid, oxygen was able to come in and react with the magnesium. So what we ended up down here with was magnesium combined with oxygen. So then after the lab, once the crucible had cooled, we got the final mass of the crucible, the cover, and then the product. And what we would find was that the mass of the crucible cover and sulfur, or in the case of the lab that we did, magnesium, had increased. And that increase in mass was due to the oxygen that was reacted with and attached to the magnesium in our lab. So for this pretend data that we have here, instead of doing magnesium, he's using sulfur. So we have the mass of the empty crucible cover at 20.740. So that would be the mass of just the crucible and its lid. So there it is, empty. And then he went ahead and added some sulfur to it and got the mass of that. So now we have the mass of the crucible, the cover, and the sulfur. So to figure out the mass of just the sulfur then, well, we have to isolate then the crucible and the cover, and we've got the mass of the crucible and cover up there. So let's get the mass of just the sulfur. And that's going to be equal to the mass of the crucible, cover, and sulfur at 20.955 grams minus the mass of just the crucible and cover. So that we have left is the sulfur, and that was 20.740 grams. So that tells us then that the mass of the sulfur is 0.215 grams of sulfur. So now, just like in the lab that we did in class, the student would strongly heat this, and when he does that, it'll pop open the lid and he'll let in lots of oxygen. So oxygen will come in and react with that sulfur, and when it does that, that's going to increase the mass. So we heat it up, let it react, and it cools down. Now we've got to get the mass of the sulfur and oxygen product. So the mass of the sulfur and oxygen product would be the mass of the crucible, cover, and final product, which is 21.170, minus the mass of the crucible and the cover, which is going to be 20.740 grams still. When we subtract those, we find out that there is 0.430 grams of product. So what is inside the crucible now at the end of the experiment weighs 0.430 grams. So what's happening with this lab is we're combining sulfur with oxygen, and so it's going to be sulfur plus oxygen, and it's going to yield some product. We need to figure out what that product is, what the empirical formula is for that product. So to really figure that out, we need to know how many grams of oxygen were absorbed, so how many grams of oxygen came in and stuck to that sulfur inside there. So the sulfur weighs 0.215. The sulfur plus oxygen is 0.430. So to figure out the oxygen, we would subtract this number, 0.215, from that number right there. So our mass of oxygen is going to be the 0.430 grams minus the mass of just the sulfur, which is 0.215 grams. And that turns out to be 0.215 grams. So we do have the same mass of oxygen as we do sulfur. That doesn't mean it's a 1-to-1 ratio because we have to do formulas, empirical formulas, and molecular based upon moles. So now we're going to need to convert both of those into moles, divide by the smallest, and use that to get our empirical formula. So let's take our data from the lab, our grams of sulfur and oxygen, convert those into moles, and we do that just using pretty standard mole conversions. I'm going to use several sig figs when I do this just so we get nice long numbers at the end, and then when we divide we're more likely to get good even round numbers. And when we set these up, cancel out units, we get 0.00 0.6705 moles of sulfur, and we get 0.01344 moles of oxygen. Next step is to divide by the smallest, and the smallest is the 0.006705, and that'll give us our ratio. So we would have 1 sulfur for every 2 oxygens. And that means our formula, our empirical formula for this is going to be SO2. So there you go. Really similar to the lab we did. I like this kind of question. I like lab-based questions because labs is where it's all at. In the real world, they don't just hand a chemist some numbers and say, here, figure out what the empirical formula is. They have to do a lab to figure this kind of stuff out. So this kind of technique, this kind of data analysis is really important for you guys. Especially those of you who are planning on going to college and doing anything remotely related to science. You're going to have to do lots of labs, so lots of this kind of stuff. It's good to build those techniques now if you can.